Today we start domain and range of functions. So hopefully you have your notes right in front of you. You're going to take some notes just like if I was here. And stay with me. I'm going to move some things around. Okay, here we go. This year we talked about discrete graphs. Those are when there are just specific points plotted. That would be like a scatter plot. And if you look to the left here, there are examples of scatter plots. We also did continuous graphs this year where the points are connected. So we did linear, which are the examples on the top. And we did some non-linear. Looks like one of those is linear. But if they're curved, on the bottom. Every time you have a graph, you have what's called a relation. And it's the set of ordered pairs. So when you have either a discrete graph or a continuous graph, you have some ordered pairs. Oh, I think I can do this. Yes, I can. A relation can be represented by a set of ordered pairs in an input-output table, a mapping diagram, or a graph. So there are three examples here. The input-output table, as you see, looks like a table of values. Mapping diagrams, sometimes people are confused by those, so make sure you're looking now. When you do an a mapping diagram, this says -1 maps over to 1, so that's like the ordered pair -1, 1. We have the ordered pair 0, 2. We have the ordered pair 1, 3. We have the ordered pair 2, 4. Last, there's a graph. And even though we can only see this many points on the graph, there's more points. There are more points than what you see. There's actually infinite points. And that's important because when we learn domain and range, this is a continuous graph. There will be more points that we don't see that we have to include when you find domain and range. Domain is the set of input values. Input is otherwise known as the x values of the ordered pairs in a relation. Therefore, range is the output values, or the y values of the ordered pairs in a relationship. So remember, domain comes first in the alphabet, D. R comes second in the alphabet, R, DR. I comes before O. X comes before Y. Domain is your input. Range is your output. Domain is X. Range is Y. So we're going to focus only on domain today. So if I give you this input table right here, and I say, give me the domain. These are a bunch of points. Because they're a bunch of points or ordered pairs, your domain, you make some kind of squiggly. It doesn't have to be perfect. You're going to write each of the domain or x values. And that's it. So the domain of that input-output table is 1, 3, 5, 7. Mappings are the ones where you have to understand what's going on. If it helps you, when you have a mapping, you can write the ordered pairs that are mapped. For example, this -2 input maps to 15. So that's -2, 15. Then the 0, it maps to 10. 0, 10. The 2, whoops, I forgot one. 0 maps to 20. 0, 20. The 2 maps to 5. 2 to 5. And finally, this 4 maps to 20. There are 5 ordered pairs in this relation. when you write your domain, it is the set of x values. So, essentially, you're just putting the input values. -2, 0. I am not going to write 0 again. You do not have to repeat them. 2, 4. And that is your example of your mapping diagram. So finally, if I give you a graph that is discrete, you look for the ordered pairs given, and I can see that they're there. If it helps you, you can write them down. -2, 3, -1, 3, 0, 3, 1, 3, and finally 2, 3. So again, this lesson is about domain. So all you need for domain is to give the set of x values. -2, -1, 0, 1, and 2. Now those were about tables, maps, and discrete graphs. So it's going to change a little bit as we continue to go. So we're going to start on the back here in a minute about continuous graphs, but they're going to have boundaries, and it may not make any sense to you yet. It says graphs are parts of a line, and there are many points on the graph. It also includes all fractions and decimal values of x and y. And because there are too many x values to list, you guys are going to use inequality symbols. Now, we didn't do any inequalities this year, but in algebra, they're very important. So you'll be using inequality symbols to write your domain. If you have open circles, you're going to use less than or greater than, just like you did in 7th grade math when you graphed inequalities. However, if you see a solid dot, you must include a line underneath which represents less than or equal to or greater than or equal to. So remember, when we turn this over, if we see open circles, it is not equal to. If we see closed circles, it is equal to. So the directions here is still the same. We are going to use the domain, or finding only domain, and we are going, what happened there? Okay. We are going to use the x-axis to determine how far left and how far right. This is the key here. You're going to hear me say this a lot. How far left to how far right. Why did that not change colors? Yikes, I don't know what I did, guys. Let's try this. How far left, how far right. I don't want to use that. How do I get rid of that? I think I have to use this thing. Okay, we'll try that. Alright, it says, when finding domain, how far left, how far right. I don't want to use that. Okay, maybe I don't have to. Alright, so I'm going to grab my highlighter if it works. And I'm going to highlight on the x-axis. Now the x-axis goes left to right. And I'm going to start highlighting right here. I'm highlighting right here because that's the farthest left that my graph goes. Now I'm going to go and highlight this all the way across until it hits right here. Now you might be saying, why did I do that? Well, I'm going to grab green here. This line of this graph starts here and it's up to here. I'm going to delete that here in a second. The graph is the green line. I have the pink line to indicate how far left to how far right it goes. I'm going to get rid of that green line. So what I'm looking for is the lowest number to the left. And when you go left from the origin, they are negative. So if you look how far left that graph goes, that graph, I'm going to put a D down here, that graph goes all the way to -7. 1, 2, 3, 4, 5, 6, 7. Then I'm going to skip a space and put in X, because domain is X. And I'm going to see how far right this goes. So I start again at 0, 1, 2, 3, 4, 5. I'm going to put a 5 here. Now make sure you know why I went from here, -7 along the x-axis all the way to here, which is +5. I hope you all see where I got those two numbers from. Next, I'm going to pay attention to the dots. This dot is closed in. This dot is closed in. When they are closed in, we're going to put a line underneath because we're picking an inequality symbol here. When you go in between these areas, you're going to use a less than sign. Now, I know I'm not here to answer your questions. However, let's talk about why it's less than. This is the number 5 here. Then there's the number 4. And then a 3. Then a 2. Then a 1. Then 0. -1, -2, -3, -4, -5, -6, all the way to -7. So these numbers represent my domain because it's the biggest one is 5, and it goes all the way down to -7. So we're going to use less than or equal to symbols there. Now you might be confused, but some of you might understand. So let's go to the second one and see if it makes a little more sense. Remember, you are asking yourself, how far left does the line go? Now I'm going to make this one yellow. Here's my line. You use your x-axis as your guide. How far left does that go? So I'm going to go on my x-axis and I'm going to start right here. And I'm going to go to the right all the way to here. Because that yellow line starts to the left where my pink line starts and it goes all the way to the right. Next, you determine what those numbers are. On the left, right here, is 0. Let me put my D for domain. I'm going to skip a space and use X because domain is X. I'm going to go all the way to the right. This one goes all the way to 9. 0 to 9. I'm paying attention to my circles. The one here is solid. It's a solid circle. Since it's solid, we're going to put a line underneath this. This circle over here where the 9 is open, so I'm not putting a line. Because this yellow line is in between 0 and 9, I'm going to put a less than sign there and a less than or equal to there. Every time you write your inequality, the symbol should go the same direction. So why don't you try number 3 on your own. I'm going to give you about 30 seconds to look at it, and then I'm going to go over it. How far left to how far right? Okay, so the farthest left that this goes is -8. I skip a space. I put in X. How far right does it go? It goes to 3. Then I pay attention to, there's an open circle on the right. There's an open circle on the left. I'm not putting a line under it. And I'm going to put a less than sign. And you just did your first 3 continuous graphs, finding the domain, but there's still more it's going to change.